Let's look at a very important topic in computer networks, that is network delay. So what do we mean by network delay? A network delay is the time taken for a data packet to travel from source to destination. It also known as latency and generally measured in milliseconds. So what are the factors that affects a network delay? It involves routers, nodes, internet backbone, and servers. So a data packet is nothing but a smallish chunk of data to be transferred between the nodes in the computer network. So the delay, if we talk about the delay, is not a single thing. It's the combination of multiple delays, namely processing, queuing, transmission, and propagation. So let's look at them one by one. So the processing delay is the amount of time taken by a node or a router to examine the packet header. Let's look at what a packet contains. It contains a header which involves the source IP, the destination IP, and the tail, which involves the algorithms to encode and decode the packet. So that time to examine the packet is considered as the processing delay. The second one being a queuing delay. It's the time a packet that waits in a queue before transmitting it into a propagation layer. So if you look at here, this is the actual transmission line, and this is a source node, and this is a destination node, and these are the packets that are traveling. Okay, so the amount of time this packet is spending in this queue before getting transmitted into this actual transmission line. So that is called as a queuing delay. Next one is the transmission delay. It is the time taken by all the bits to be transferred from this queue to the actual transmission line. So all the bits like before transmitting, uh, total amount of time that it takes to push all the bits into the actual transmission line, it is called as the transmission delay. And the last one is being the propagation delay. It is the time like the data packet to travel from one node to another, like end to end, whatever distance it could be. So that time is considered as the propagation delay. Now let's look at the mathematical view of delay. So we can calculate a transmission delay as size of the packet divided by its bandwidth. And for the propagation delay, we can calculate it as a distance divided by speed of the signal. So let's look at the example. If we have 8 MB of packet and it travels over the 10 Mbps link, or we can say Wi-Fi or router, so how much will be the transmission delay? 8 divided by is equals zero point 0.8 second transmission delay. So the longer the distance, the longer it will be the propagation delay. So now let's look at the fundamental difference between bandwidth and latency. Sometimes it's get confusing terminologies. It's very simple. So bandwidth is the data transferred per second, and the latency is just a time delay. So if we take a real life analogy, if we consider a highway, so the width of a highway is can be analogized as the bandwidth. The more the width will be, the more vehicles it will accommodate. Just like that, the more the bandwidth, the more data it will accommodate. And the latency is just nothing but the distance to the destination. So why network delay matters in system design? So if we take an example of 10 microservices and a data packet travels to each microservices which has 50 milliseconds of delay. So 10 into 50, it will be a 500 millisecond of delay, and that is considered as a huge when we are designing a systems. So it impacts distributed systems. It affects the database replication, and it's very critical for things like gaming, video calls, and real-time systems where we cannot afford to have a more latency, and it's not reliable, fast, and secure by default. So how do we reduce the delay? There are multiple ways we can follow to reduce the delay. Let's look at them one by one. For propagation delay, we can use CDNs. What is the CDNs? These are content delivery network. These are the edge nodes that actual servers placed near to your geographical location. So if we take a look example of a Google. So if we hit a google.com in your mobile or a laptop, what it does, the request goes to the Google server and again come back to your device. So the data is traveling a far way. As we all know that Google Center is in US, uh, and the data will travel a lot, like from India to US, it will be a huge distance. So what we have come up with is a CDS. So what if we place the node, the servers near to India only? So that data packet should not travel a lot and we can reduce a network delay. So these are the uh, terminologies between these CDNs. Next we have is transmission. For transmission, we can compress the data. Compress the data that it contains a header, payload, and a tail. If we compress it, the more data will be transmit in the transmission layer. Or we can increase the bandwidth also. If we take an example of a real world analogy, we can consider it as a pipe. If we increase the diameter, the more data will flow through it. Next one is the queuing delay. As we all know, in the distributed systems, we manage the queue using load balancing and auto scaling. Just the same way, we can manage the data packets and reduce its time spending in the queue before getting transmitted into the actual layer. So we can use load balancing and auto scaling. And for processing delays, we can use caching and optimize the servers. So that node needs not to be recompute the packet again and again. If we cache the results, it will reduce the network delay to a drastic low point. So these are the ways that we can use to reduce the network delay. And we have looked at why the network delay is important in CN area. Yeah, thank you.